Good day, students, grade 12 in particular, and welcome back to my series where I'm still running against the hope of my calling, and that is to retool you in mathematics. For a merit of reasons, today I want us to solve this problem involving sigma notation, at least in more ways than one. And in the kick of a finger, let's check what are we having here. They are saying solve for p such that this equation is true. Now, this equation is not just an equation. We are talking about a sigma notation. So, well, we do have got two situations here of sigma, but on the left side of the equation, we do see the sum to infinity, of course, where the starting index, that is k there, equaling to 0 all the way to infinity. So we also have got the general term of that particular sum, which is your 27 multiplied by p, where p it's the ratio between two consecutive terms just right here, raised to k plus 1 power there, and that is equals to also a sigma again, but this time around the starting index is r is equals to 3 all the way to 14. And then now you do see a linear situation here, which really demystify the arithmetic sequence. But in this case, it's going to be the arithmetic series because you are dealing with the sigma, which means the sum of terms. All right. So now, let's try to understand what is happening. I'm going to start on the left-hand side of the equation. We do see the sum from k is equals to 0 up until infinity, and we have got 27 multiplied by p to the power k plus 1. Guys, I want to warn you here. Now, this is a sum situation, not just the sum, but the sum to infinity. So the sum to infinity can only exist if the ratio between two consecutive terms or successive terms is between -1 and 1. By that, I mean your ratio must be in between -1 and 1 in order for this sum to exist. So that means that this p, which in this case is representing the ratio between those two successive terms or consecutive terms rather, it must be in between -1 and 1. Remember, whenever we deal with the sum to infinity, we are primarily talking about a geometric convergent series. It must converge for the sum to infinity. That means your ratio must be in between -1 and 1 there. So if you find your p to be outside this bound here, it means you are wrong, extremely wrong. So let's try to evaluate it, and we'll also try to evaluate the other side of the equation. So the best way to really treat the sigma notation is to expand the first three terms of that particular sum. So we are going to start from k is equals to 0. That means in a position of k in here, we are going to put 0. So it's going to be 27. If I put k as 0 there, I'm going to get a p plus 27 multiplied by p. If I put 1 now, just in a position of k, I'm going to get p squared, and then a plus. I can also get the third term at least. And then I'm going to get the 27 multiplied by p. Now you put 2 here where there is k, you're going to get a cube there. So this is going to continue because the number of terms is infinite there. All right. So let's try to find the ratio. The ratio, like I said, it's p, but it's important that you find the first term and the ratio of this occurrence. Well, let's see. A is the first term of the series, which is 27p, and the ratio between the two is primarily your t2 over t1. You can say t3 over t2, and in this case, it's going to be 27p squared over 27p in there. Let me put it properly. 27p, which is equals to p there, if you try to simplify it properly. So you have got A and R, which is what you need when you are dealing with the sum to infinity. So I'm going to write the formula properly for sum to infinity, which is S, the sum to infinity, which is equals to A divided by 1 minus R. Now pay attention, what is your A? Your A is this one. So you're going to have got 27p, divide this by your R. Your 1 minus R, which is 1 minus P there for this particular equation there. Now I'm going to do the very same stuff in the on the right hand side of the equation, which is basically this one. So let's do it together. We've got the sum from R is equals to 3 up until the 14th term then. And then now we are going to have 30 minus 3R. Let me confirm that. So that is from 3 to 14, and we've got 30 minus 3R. Now check. Let's expand it as well and find the first three terms. We can even find the last term basically. Now, let me substitute 3 here in a position of R to get the first term. So if I do that, I'm going to get 30 minus 3 times 3, which is 9. So it's basically like 30 minus 9. So that is 21. And then a plus, if I take 4 now, so it's going to be 30 minus 3 times 4, that is 12. So it's 3 minus 12, which is 18. And then plus, now if you take a 5, it's going to be 30 and then minus 15, because 3 times 5 is 15. So it's going to be 30 minus 15, which is 15. I can say plus, it continues up until the last term. So this is the last term, all right? This is the last term. I'm going to put it just right here. So it's going to be 30 minus 3 times 14, and then that is going to give you negative 12, all right? If you do that nicely. Now, check something here. This is the sum, this is the arithmetic series. So what do you need? You need your first term, that is your A, which is 21. You also need the difference between two consecutive terms, and that is to get the difference there. If you do it nicely, let's check what are you going to get there. Let's try to really do the difference. And then that should be 18 minus 21, I guess, should be negative 3. That should be negative 3 there. And then you also need the number of terms. So the number of terms is going to be the top minus the bottom there, and you need to add 1 there. That is 14 minus 3. And don't forget to add 1 there. So let's see there, what do you get for the number of terms? So this should be 11 plus 1, and that is going to give you 12 there for the number of terms. Now, so the number of terms here is 12. Let me try to really put it in this way there. So the number of 12 is, the number of terms is 12 rather. So let's try to find the sum of this one. Well, we are going to say, well, this Sn is equals to n over 2 into 2a plus n minus 1 times d. Well, our n is 12 divided by 2 here. So we are looking for the sum of the first 12 terms. Into 2a, our a is 21, I guess there. And then a plus n is 12 minus 1 times the difference, which is negative 3. And then let's see, what do we get? We get 6 into, that is 42 there, minus, that is 11 times negative 3. And that is negative 3 there. Well, let's see, we get 6 into 42 minus 3, that should be a 9 situation. And as a result, it's going to give us 54. The other way to treat this sum, because we know the last term, I'm just seeing it now that we could have used the other method, which is to say the sum of the first n terms is going to be n over 2 into a plus the last term. So the n is still 12, divide this by 2. A is 21 plus the last term. What is the last term? The last term is minus 12 in the series, right? So I can say minus 12. So this should be minus 12. Let's see what do we get there. So this should be 6 multiplied by 12 minus 21 minus 12. This should be a 9 also, and then that should really give us 54. So this is the best way to evaluate this sum. So it means that we have got the sum to infinity, which we know the expression of now, and this value here is 54. We just found it now. So let's just copy that sum to infinity, which was this expression, and put it just right here. Well, this will be equals to 54, and if we solve it algebraically, let's see what we're going to get. We're going to get 27. P is equals to 54, 1 minus P there. And as a result, we are going to get 27P, which is equals to 54 minus 54P. Now, let's see what do we get. So 27 P plus 54 is 81. P is equals to 54 there. Therefore, P must be equals to, you divide both sides by 81, you get 2/3. Thank you very much for watching. I hope this was beneficial. See you next time.